Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the event horizon here on Astronomy.fm radio. That means it is another Friday evening. This one is June the 21st, 2019, 9 o'clock in the evening. For those of us here in the eastern portion of North America, Universal Time would put it on June 22nd, 2019, about 1 o'clock in the morning. So that means for the next hour, we are live, and happy June solstice, everyone.
Yes, happy solstice, everybody.
Yes.
And of course, we're going to do what we always do, Marty. We're going to take over the world.
That's right. We'll stop short at the universe, but we'll take over the world.
No, I leave the universe to Ming the Merciless.
There you go.
If we keep competing with him too much, he might come after us.
We'll send the Wednesday people after him.
Well, you know what the funny thing is, Marty, saying about the Wednesday people, is that I was listening to a certain politician. He said that the reason that we're creating Space Force is to go after those space pirates. No,
that's right.
What the heck has Marty and Diane done now?
That's right. We'll take them on. That's right. We'll be the Robin Hood of space. All right. Want to welcome everybody in our chat room tonight. We've got you and me, of course, Starstorm, Glenn, Black Project, and Evil Spock just joined us. Don't forget, come on over to the chat room. Go to the homepage, astronomy.fm. You'll see near the bottom where it says chat. So click on that and come on in. If you want to have a question, if you have a question for us, you can type it in the chat room, or talk to other people in the chat room too if you got questions for astronomy and stuff like that. So it's fun to participate with our live audience during this live presentation. Don't forget, we're going to repeat this program every 4 hours for the next 24 hours, including other programs such as First Light and Jodcast coming up after the event horizon.
And of course, the best thing is, of course, this show will be vodcast. Technically, it is a video. Hopefully by tomorrow evening, and of course on the Space Pirates Facebook page and on the AFM Facebook page, you will get last Wednesday's Space Pirates along with the links.
There you go. That's our Space Pirate radio page. I had my own Space Pirate page, and Facebook blanked it out, canceled it out. They've been doing that a lot. Like,
and
because it wasn't a real person, so they offed it. It's like, thanks a lot, guys.
And of course, the nice thing about the show is when we're live, the chat room is in use. Just come along to astronomy.fm/chat. Make up a name, keep it nice and clean, please, and we'll mention it on the air. And don't worry about a password. Come in, join in the conversation. We've already got a conversation going already. So, yes, this is the whole point. It's interactive. Yes, thank you, Starstorm. And, of course, the nice thing is we can bounce off your comments. You can bounce off our comments. You can make jokes, share the jokes. Sorry, what was that? As long as they're appropriate, yes, thank you.
Yes, in the mirror universe, neither one of us has a beard.
This is true.
Mm-hmm.
And in the mirror universe, we're both carrying knives and probably killed the previous host of the show.
That's right. Hey, maybe we're the normal ones. Maybe we are the evil universe already because we have beards.
Maybe we supplanted the origin universe pair.
That's right. Glenn says, how real are any of us? Anyways.
Well, we're all star stuff, Glenn, so that makes us fairly real.
And we are mostly a giant force field.
Yep.
If you take all the molecules and atoms within us, and you crush them down to basically to the same density as a neutron star, we would be a microscopic speck.
Of course we go
staying
on
at,
rants, Glenn.
but staying at our same mass, by the way. So try to imagine something like, take a grain of salt and crush it up as fine as you can. Take one of those little subgrains, that's the size that we would be with the same amount of weight that we had. Let's say, let's pick a random number, like 200 pounds. So that smallest little particle of salt that you could still see would weigh 200 pounds if it was basically at the density of a neutron star. So basically...
Neutronium, very tasty.
That's right. So basically we are... Like atoms are mostly empty space, so we are mostly a force field. That's all that, like 99.9999999% of us is actual matter, and the rest of it's basically a force field.
Now, Glenn says, "And are not the stars in our imagination?" Well, there's a theory that this is a very complex holographic universe where we're actually a computer simulation. If we're a computer simulation, I think whoever created it really needs a couple of Gibbs or two.
I was thinking
we're way out of control.
We need some more computer programmers, I think. But I can imagine this being a sim world. Ever play that game, that sim game? I thought it was stupid,
I've never played The Sims. I used to play Lara Croft Tomb Raider occasionally, many, 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 many years ago. You had to use your keyboard.
I haven't played any computer games except Solitaire in a long, long time. Well, let's find out what's going on in the universe. We got some launches coming up and some de-launches coming up. Let's see, the 24th at 7 p.m. So that's 3 more days from now. Space Station Expedition crew will be leaving the space station. That's Expedition 59. So they're few astronauts, cosmonauts, and so forth that will be coming back home to the Earth from orbit. And then also on the same day, a SpaceX Falcon Heavy will be launching with some tech payloads. This is actually a U.S. Air Force Space and Missile Systems Center launch. And they'll be launching the Deep Space Atomic Clock, Space Environment Test Beds, Green Propellant Infusion Mission, and Enhanced Tandem Beacon Experiment, and other payloads too. So that's all coming up from launch 39B, Launch Platform 39B.
Okay. Now, having said that, this is a link that Black Projects gave me earlier this week.
Okay.
It's a little bit of citizen science. The Planet 4 blog, it's a Zooniverse project blog, building the NASA Citizen Science Community Meeting. So basically, this was written in Tucson, Arizona. The writer is with Planet 4 Pi Cindy Henson at the building of the NASA Citizen Science Community Meeting. Aim of the workshop is to bring together researchers engaged in successful citizen science projects, citizen science experts, and platforms supporting citizen science projects, which includes the Zooniverse, the NASA Science Mission Directorate, and researchers interested in applying citizen science research to their programs. So there was an invited talk given, and slides highlighting the science results and success of Planet 4, and of course advertising Planet 4 terrains and Planet 4 ridges. So yeah, it is exciting that people in planetary and the astronomical community see Planet 4 as a successful project. It's obviously due to the large part to the contributions of the volunteer community. It was great that they could actually talk about the first paper, and also mention the science team is working on 3 other publications right now based on the first fan and by tech catalog. So basically what Planet 4 is exploring Mars with 150,000 Earthlings. And there's a nice little graphic put in there by Meg Schwab for the Germany and Queen's University Belfast. Now, as I say, there are some of the images that they've got there from the paper. Do have a look at it and do enjoy it. And more importantly, get involved.
There you go. I got a couple of citizen scientist projects listed by the AAVSO, too. All set with your article? Done with that one? All right. Let's see. AAVSO alert notice 668. Star is V1047 Centaurus. It's Nova Centaurus 2005 is rebrightening. So check that one out. Let's see what they got it usually as 14th. Usually it's at 15th magnitude, and it's brightened up a full magnitude, 14th magnitude. So hard to say how much brighter it's going to get, but it's definitely starting to brighten up. So you can let me put a link into that into our chat room. So if you want to help monitor a nova that's actually brightening, you can do that. Get some comparison photographs. Take one like every day or so, and at same exposure time, and see how it actually changes over time.
I've just been asked to. Sorry for interrupting for a second, Marty. Asked to give a shout out to a friend of myself and Glenn's, who's a bit poorly at the moment. So get well, mate, and we'll be lifting a few pints soon.
Who's that?
Thanks. My friend Simon. Simon is an amateur astronomer. He was actually around at the time we were all involved in SLU, Marty.
Okay.
So he's an ex-SLUie, and he's an amateur astronomer and also a radio amateur. So he does listen to the show on the actual podcasts.
Right. Got another citizen scientist project, alert notice 669. Let's see, it's a Dr. Paula Sicoti of the University of Washington informs us that the Hubble Space Telescope observation of the cataclysmic variable V386 Serpens, originally scheduled for last month, had been rescheduled for August of 2019. So they need some observations of that star. See, I get some data. Visual magnitude 18th magnitude. So if you are well into astrophotography and you could help with this project, this would be one that you could actually help a project and help protect the Hubble Space Telescope. Let me put this alert notice into our chat room also. And both of these you can actually get yourself at the American Association of Variable Star Observers, aavso.org. So 2 projects you can participate in. Let's see. Well, real quickly, we got an occultation. Happened or didn't happen. It's on the 21st of June, so I guess it's probably over now. The moon in front of Gamma Capricorn, visible from South Africa and South Australia. Haven't heard any results of the Saturn moon occultation. Occurred a few days ago on June the 19th, so I'll have to look around some publications and see if anybody's gotten some images of that. How about you, Optronics? You're listening out there tonight. Did you get any images of that? It was in your area.
Yeah. If you are listening, please come in and tell us. We'd love to hear from you.
Mm-hmm.
Okay. Now, staying in the relative close solar system, they found a huge mass under the moon's largest basin. So what they're thinking is, does the massive metallic core of a primordial impactor lie buried under the South Pole Aitken Basin on the lunar far side? Now, what it is, one of the moon's most fascinating features, and it's really one that's hidden from our view on the far side, is a huge impact basin known as South Pole Aitken, SPA. It's so named because it's 2,000 kilometer, 1,250 mile diameter, extends from the crater Aitken on its north rim to the lunar South Pole. It's immense. It's second only to Mars's Hellas Basin as the largest impact in the solar system. Now, SPA isn't particularly obvious in spacecraft photos, somewhat darker center hints of metal-rich material dredged up from the deep crust or uppermost mantle, but topographically speaking, It's an unmistakable pit up to 13 kilometers deep. Now, earlier this year, Chang'e 4 lander dropped in on one particular deep spot near the basin center. So geologists have long suspected that the oval-shaped SPA resulted from the slow, oblique collision of an object roughly 200 kilometers across that didn't penetrate the moon very deeply. Now, with analysis of gravity and topography data that's identified a huge mass buried under the basin. So a team led by Peter B. James, Baylor University, which announced the discovery in Geophysical Research Letters, combined topographic maps of the basin with the best available data from NASA's Gravity Recovery and Interior Laboratory, GRAIL, mission. The team suspects that the impactor's iron-rich core may have dispersed itself into the moon's upper mantle, perhaps leaving a concentrated blob with roughly the 5 times the mass of the Big Island in Hawaii. Okay, so mass cons or mass concentrations are nothing new. They're typically found under many of the other lunar basins, but these tend to have a bullseye structure with a very deeply buried ring of lower density material sandwiched between the denser core and the outer ring. So this tells researchers that the impact removed enough overlying crust to allow a plume of dense metal-rich mantle to rise towards the surface under the basin center. But now the massive blob buried 400 kilometers under SPA has a different gravitational fingerprint. So James and his colleagues think that it could be a holdover from the moon's formation, a concentration of dense metallic oxide created as the last of a deep global magma ocean cool and solidify. But why haven't these been seen elsewhere? And why should this be one large one? This happened to lie under the largest lunar impact basin. Perhaps a better explanation for this excess mass noted in a Baylor press release is that the metal from the asteroid that formed this crater is still embedded in the moon's mantle. The impactor most likely would have had a differentiated layered structure with a silica exterior and an iron-nickel core. The computer simulations show that after striking the moon with a glancing blow, the metallic core would have ended up as a lump beneath the basin, concentrated enough to create the gravity anomaly recorded by GRAIL. But it's dispersed enough that it didn't sink en masse towards the lunar core. Now, when you think about it, this is the largest and deepest lunar impact basin that's affected the rest of the moon when it formed about 4 billion years ago. Obviously, it's redistributed huge volumes of crust all around the lunar globe, and it may have been implicated in creating the magnetic anomalies all over the lunar surface. Also, SPA might have altered the moon's rotation. So now dynamicists will be looking closely to see what role this massively newly discovered lump might have played in altering lunar history. Let's face it.
Where's it located?
South Pole Aitken.
South Pole, gotcha.
So obviously this is something we can't image the area.
Right.
We can only see it if we send a satellite there.
Mm-hmm. Speaking of satellites, by the way, this is coming up on the 10th year anniversary for the Lunar Reconnaissance Orbiter.
Mm-hmm. When you think about it, LRO's done a really, really great job.
Mm-hmm.
It's one of those missions that's still giving great science.
Mm-hmm.
When you think of the petaflops of data that was created by this mission, and actually going through this, we barely scratched the surface.
Mm-hmm. There's
probably another 100 years worth of research just waiting to happen with this information.
Mm-hmm. Well, if it doesn't stay in lunar orbit, then eventually it will scratch the surface.
Oh, yeah. But then again, they use things like that to look at seismic waves and how they go through the moon.
Mm-hmm. Well, the LRO is one mission I have neglected to really get into and check out those lunar images. So, something I've always been meaning to kind of get back to and check out those super close-up images of the moon, which a lot of people have neglected that, actually.
Well, the thing is, I put the link into chat for LRO.
Okay.
You can actually, they have a page called LRO LORC Target Observation Request. It shows existing targets in the LORC database. So this is something where you can actually think about where you would like to have imaged, and maybe put a request in and see what we can do. So obviously, the moment, the view I'm in is showing the master target list. And there are just so many layers that you can play with that you could probably spend a whole weekend just working your way around this one site.
Of course, the usual question for LRO is, can it actually see the obelisk?
There is no obelisk.
2000.
And then if you're thinking of the monolith was buried in the bottom of the Tycho.
Monolith. There you go, monolith. Obelisk, monolith.
And that was only, its existence was only mapped through gravitational anomalies anyway. No, magnetic anomalies, I think.
I don't have that music. I should play that music, but I don't have it. So.
Yeah, I do. I've got the music.
I just thought of it. Oh well.
But seriously, when you actually think about this program, it was launched on June the 18th of 2009. It has an orbital period of 2 hours. Orbital height is 50 kilometers. Speed on orbit is 1.6 kilometers a second. It cost $504 million US dollars. That was back in 2009. And of course, LCROSS was also launched as part of the LRO mission as well. And one of the things which has always amazed me is some of the new images of the Apollo landing sites. This goes to say, you who do not believe in us going to the moon are now totally and utterly dead in the water. Because the Japanese have imaged the Apollo sites, the Chinese have imaged the Apollo sites, and I've got news for you. What is the first thing Japan and China are going to do if they don't see Apollo hardware sitting where it's supposed to be sitting? They are going to start screaming and putting pictures up, and that would probably gut the American space program.
There you go.
So anyway, new images of the Apollo landing sites in 720p and all its glory, with an intro by Noah Petro, who is one of the research scientists at NASA Goddard.
There you go. Mars 2020 rover getting the wheels put on.
Yeah.
They've got it up on the hoist down at what's that tire place down the road there? Bell Tire. Yeah, they got it down at Bell Tire up on the hoist and put new wheels and rims on it. It's gonna look sharp. Got them really low profile ones too, you know.
Well, the really nice thing is we're building on everything we've done so far on Mars. Opportunity, Spirit, Phoenix have all contributed towards the new lander. Every time we send a lander, it tells us so much more about the surface conditions. It tells us how exactly we can build kit to last longer. And I have to admit, I totally agree with Starstorm. I'm thinking those should be, when we actually get to colonize Mars, it should be taken in, repaired, updated, and put back to work, literally. Because it's going to take an awful long time for man on Mars to actually do the exploration. And why not put those wonderful, wonderful rovers back into use, give them new software, new experiments, new jobs, and get them going? Let them help man make Mars a new home.
Well, it would actually be probably cheaper and more efficient just to build new rovers and send them there instead of doing something with those, except maybe put a cover over them and use them as like museum pieces on Mars, preserve where their last positions on Mars. But it's actually more efficient instead of refurbishing something like that, just to go ahead and build something much better, more efficient with a new one instead of trying to refurbish some old stuff like that.
Well, the thing is, you've got to launch it. It's mass. You've got to launch off the planetary surface from Earth.
It's getting easier all the time.
Yeah, but if you can just
Yeah.
refurbish something, it's also cheaper to refurbish something.
But you still got that issue of getting a manned mission there, but it's a lot easier and cheaper to get a robotic mission there.
Well, as I say, I'm just waiting for someone to put the Mark 1 eyeball. I think if I had the chance to go to Mars, I have one thing I really want to do as a survey mission. I want to take a dirigible and I want to literally map the Valley Marinaris. I want that huge Great Rift Valley on Mars. That's something I would love to spend my time mapping.
Like actually being there, you mean?
Actually being there, using maybe something like a hang glider or something, it's got a balloon for extra lift, and then just map the whole of the Rift Valley. It'd take me years.
Hang gliding at the equivalent of 35,000 feet on Earth is not a good thing, and not an easy thing.
But the thing is, having a human actually fly along and actually map, because a human can say, we need to mark this coordinate to come back and to actually go in and look at something closer. Mm-hmm. This is what happened on Apollo. One of the astronauts saw a flash of orange soil. Mm-hmm. And that was one of the most important discoveries Apollo ever made, was that soil. Because it was one of the things that helped prove an awful lot more science about the moon than ever. Mm-hmm. I see Starstorm's enjoying herself.
So, yes, but you have to get up close and personal. And have you ever been to the Grand Canyon?
She was having Fly Me to the Moon.
Yeah, have you ever been to Grand Canyon?
No.
It's huge. Okay, it's huge. But the Grand Canyon on Mars is like 1,000 times bigger. So to get up close and personal to that entire system would take a lot of people to walk around in that system. A lot of people. Like thousands or more to go walking through there to get up close and personal to be able to see a single rocket just in the right spot. So most likely that's not going to happen that way. You can cover a lot more area robotically. And then if there's something interesting, just mark the spots and then MPS it, Mars Positioning System. Yeah. And then go back specifically to certain spots that you want to do some research on. But just start scanning the whole thing with one person, not gonna get very, very far at all. Well, multiple lifetimes to do something like that.
If you were to impose the U.S., the continental United States, not including Canada or Mexico, across the Valles Marinaris, it would go from the east coast right to the west coast. Yep. We're talking 2,500 miles long and up to 4 miles deep. So the comparison is in the Grand Canyon in Arizona, that's 500 miles long and 1 mile deep. So that is the difference. It extends from the Noctis Labyrinthitis region in the west to the chaotic terrain in the east. Most researchers agree. And you know what? I really wish Gene was here, because I think Gene would love the geology involved. It's a huge tectonic crack in the Martian crust. It must have formed as the planet cooled, and it was affected by the rising crust in the Tharsis region to the west. So erosion forces widened it, but near the eastern flanks of the rift, there does appear to be channels that might or may have been formed for water. So anyway, at the bottom of the link, there's a very nice color image of the Mariner Valley, as it would be in English, north towards the top.
There you go. Oh, by the way, you're listening to the Event Horizon here on Astronomy.fm radio. It means it is another Friday evening, halfway through our program. Today's date is June the 21st. Happy June solstice 2019, about 9:30 in the evening for those of us here in the eastern portion of North America. So we still have another half hour of programming, and don't forget we got more programming coming up after the Event Horizon. We've got First Light and Jodcast coming up afterwards. So stick around for more program. But we got another half hour live of us, and we got our chat room happening here. We got you and me, Starstorm, Glenn, Black Project, Evil Spock, Cassie, and Redshirt 3. Welcome everybody in our chat room tonight. Glad to have you here. The conversations are flowing. Put some links in there. We'll put some links into our on the YouTube channel, and you can listen into the repeats of the program on the YouTube channel too. So we're doing good, everybody. Another Friday evening for us. Let's see where we want to go in the universe now. Meteor storms, a couple coming up. Yeah, we got one coming up in a couple days. We got on the 21st, we got the June Boötids, peaking on June 24th. And then starting in beginning of July, we've got the Northern June Aquilids on July the 3rd, July the 6th. The Southern June Aquilids, July the 5th. The Cypress Pisces, obviously, July the 9th. Oh, a lot of them in July coming up. The Sea Andromedids on July the 9th. And I think that's it for the beginning of end of June and beginning of July coming up for meteor showers.
And of course, if you're in the southern hemisphere, you've got the Southern Delta Aquariids. That's active from July the 12th to August 23rd. It is a strong shower. It's best seen from the southern tropics. North of the equator, the radiant is located lower in the southern sky, so therefore rates are less than seen from further south. At that particular night, the peak night is July 29th to the 30th. The moon is about 6% full.
All right. Did a little quick look for some reasonably bright asteroid occultations, and about the only one that's kind of worth noting is going to go across Australia on June the 27th. It's asteroid 22, Calliope. It's going to go across a 8th magnitude star. I'll put that link into there. It's from IOTA. International Occultation Timing Organization, which you can find at asteroidoccultation.com. These are asteroids that go in front of stars that can be seen all around the world. Let me put this link into our chat room just for this one, but you can go look for some for your country. The best ones are, if you want to do them visually, a moderately bright star like it would be nice to see some really, really bright ones, but the best lately are coming up are about 8th and 9th magnitude. A few 10th magnitude stars are going to be covered by some pretty dim asteroids, so basically the star will disappear. So kind of nice looking through a telescope at an 8th magnitude star, which is 8th magnitude. That's about as bright as Neptune, for instance. Just think about looking at a star like that, and all of a sudden it just disappears for a second and a half and then comes back. You've just seen an asteroid pass in front of a star. Got to be in the right place and the right time for that stuff, though. So it takes a little effort to do it.
Absolutely.
And
of course,
go ahead.
Say if you do see a bright and fast, like a huge shooting star, report it. It may be a fireball. So you can go to, if you're in the States, you can report it to the American Meteor Society. You can report it to the International Meteor Organization, and most countries now have organizations set up to take reports of bright fireballs or bollards and take information on just how active a meteor shower is.
Mm-hmm.
And it's a good bit of fun. You can get deck chairs out. You can make it a family event. Go out in the garden, camp out a bit, and just enjoy yourself.
Yep. If they are nice summery meteor showers where you live, that's always nice. Like the northern hemisphere has the Perseid meteor shower. That's the one you sit back in the lawn chair and look at.
Hmm.
There's some cold ones, but and then they're for kind of both hemispheres in December. I think there's the Geminids. It's a nice one, but maybe seen better around the equator if you want to enjoy it a little
Yeah.
bit more in a lawn chair. It can be
Well, it's
kinda
an
cold.
excuse, isn't it, Marty?
It
You know
is.
what? There's the Geminids coming up. Hey, shall we go to the Caribbean?
That sounds like a really good idea. Yes,
Yes.
yes, indeed. Oh, I got a little
Ah,
article here. An international team of astronomers has found a new brown dwarf, and it's one of the most massive objects of this type. Let me put this into our chat room here. A brown dwarf is an almost star.
yeah.
A star converts hydrogen into helium by a process of nuclear fusion, basically compressing the atoms together until they, with a lot of pressure, a lot of temperature, until the two atoms fuse together and form a bigger atom. And it takes a fairly good amount of material in order to be able to do that. So like stars, major stars, all the major stars you see in the sky do that. Planets do not do that. There's just not enough stuff in the center of a planet to squeeze that stuff together with enough pressure and temperature to actually fuse those atoms together into heavier atoms. So planets don't light up like stars do. Well, there's an edge between a planet and a star. So you get right along that borderline where the planet is almost big enough, but not quite in order to be able to fuse material into a star. That's called a brown dwarf. And astronomers have been finding brown dwarfs around the nighttime skies where they're big for planets, but they're dim for being stars. So it makes them more difficult to actually be able to see. Well, they are looking, and they found one that would be closer to that edge of becoming a star. And that's what this one that they're reporting was just designated. Turned out to be about 50 times more massive than Jupiter. So
Now, that's interesting because a lot of people have called Jupiter a failed star. It's made of the same elements, hydrogen and helium, as is the Sun.
Mhm.
But it's not massive enough to have the internal pressure and temperature necessary to cause hydrogen to fuse to helium,
Right.
which is how the Sun operates, and nearly all stars operate the same way. However, they said if it had been maybe 20 times or 30 times larger, that would have been a different case. We would have been just like Tatooine. We would have had a twin sun solar system, which would have been very interesting for the wildlife, because we would have had to wait in the northern hemisphere for Jupiter to go south for us to have full dark. Now, obviously, those of you who remember your science fiction remember 2010, where the creatures whose experiment humans were decided to ignite Jupiter and give the life forms on Europa a chance to come forth and live, leaving, of course, Hal and Dave Bowman as emissaries when the time was right.
It looks like this brown dwarf was, from what I could tell, just a quick look here, detected because it was actually going around another star. I think there's about 2,000 brown dwarfs have been detected, but only about 4 of them were found to be circling around other stars. So this would be the biggest one that they've found.
I'm just reading a comment in the chat room, sorry. Redshirt3 says he's received an R-spec spectrometer and he's going to try it on Jupiter. I can't wait to hear about that. Yes,
Right.
Glenn, von Neumann machines. That's what the obelisks were.
Always making new discoveries. The better the equipment gets, the more discoveries we make. Because it's really hard to see some stuff because it's just far away or small and dim. Are all things combined together. So, better the equipment, more things can be discovered. So there's got to be more big brown dwarfs out there, but the search is continuing for more of them. Where's the moon at? The moon's waning gibbous right now, so basically just past full, almost pretty soon get to last quarter. So we're starting to get in that time of night where you can get out, at least in the early part of the evening, get out and do some observations, find some of the darker, fainter stuff before the moon rises. Then it usually rises about 2, 3 in the morning, something like that. And yeah, your faint observations are kind of over by then. But when we get down towards new moon, and that's a really good time to see the really faint, fuzzy stuff out in some dark skies, if you have some dark skies in your area. That's kind of nice to have.
I think the nice thing is about the moon is you get some really nice occultations.
Mm-hmm.
You get stars, you get planets, you get asteroids, and etc. And in a lot of cases, for me, that just makes it the more fun. So when it's full moon, pretty much everything is blotted out. But hey, there's things you can do. You can look at Mare, you can look at certain of the larger lunar features.
Mm-hmm.
As the terminator shifts, it would be giving you a different perspective, not just on the Mare, but on the rills, on the mountains, and actually on the craters. Watching the peak in a crater, the shadow change,
Mm-hmm.
grow, is really fascinating sometimes. And I know people that still get lost at night, sitting there watching the whole thing unfurl for them. And some of them take images of it, some of them just stick the old Mark I eyeball to the telescope and just have a whale of a time.
Mm-hmm.
You can actually... The other good thing is you can actually image and see the moon in daylight. So if you're really bored, you can go outside, get your telescope going, and have a bit of fun and image the blue moon.
Careful.
Oh yes, we've got to be careful. Mustn't point it at the sun or anything.
That's
But
right.
in that case, you just buy a solar telescope, and do it that way.
Mm-hmm. Or a solar filter for your existing telescope. Don't forget the finder. Either get a filter for your finder or get it completely covered so you're not accidentally going to look through the finder when you're doing your solar observations. Very important to do that.
That's why Galileo went blind, by the way.
Did he try that? Well, I think he did some pinhole observations of the sun. Dimmed it down as much as possible, but still not quite enough.
Now, Glenn has made a comment in the chat room. This is why you need to be in the chat room. He's read that most stars are binary. That's actually quite correct.
Yep.
Perhaps up to 85% of stars are in binary systems, with some in triple or even higher multiple systems. In fact, with Evil Spock in the room, it means I can actually say the fact that there's the Eridani system, which is a triple star system, and the Alpha Centauri system.
Tatooine.
Yep, that was... Yes, it does. So, as I say, I'll put the link into the chat room, and it's from the Australian outreach group, Australia Telescope National Facility.
Mm-hmm. So, by the way, just after sunset, if you got some pretty good northwestern horizon from our northern hemisphere perspective, Mercury and Mars are actually pretty close together, so you might want to see if you can try spotting those two. Be a little bit difficult, especially if you can get them just after the sun sets. That's a little bit better, but also you can do some daytime observations of Mercury and Mars. If the magnification is low enough, you should be able to get both of them in your eyepiece. Venus, still the morning star. I'll have to check and see. Let me check my program here real quick and see when... Yep, it's actually starting to pass behind the sun, so another 2 months, and that's kind of interesting. Mars, Venus, and what is that object right there? Regulus. Technically, we're going to have a conjunction between Venus, Mars, and Regulus with the sun in August. So not going to be able to see it, but it'll be visible. So. We'll get Venus back in our evening skies after another couple of months. So after August, it'll it'll start getting there. So right now it's still in the morning sky.
Now, an interesting fact for you is from Epsilon Eridani, the sun will actually appear as a 2.4 magnitude star in Serpens. Not many people know that. The actual system has 2 belts of rocky asteroids at about 3 and 20 AU from the star. So this is also a known star system to have planets. And at least the ones for Epsilon B are actually thought to be close enough to an Earth type, maybe, to support life. Mm-hmm. And of course, it's not that far away, cosmically speaking, either. I think it's something like 20 light years. I'd have to here we go, 10.475 light years plus or minus 0.003. A little over 3.212 parsecs. Absolute magnitude 6.19. There you go. Not many people know that.
But now they do.
Now they do, indeed.
Just, by the way, on the sun, a little bit of solar wind activity, speed 373 kilometers per second, density 4.77 protons per cubic centimeter. So not really much of a storm. I think it was from some coronal holes. We're getting a little bit of extra particles coming from the sun. No sunspots, though. It's been over a month since we've actually had a spot on the sun. And even in ultraviolet wavelengths, the active regions on the sun have diminished considerably, too. So not a lot of action on the sun. We're definitely at solar minimum. So one thing to look forward to in another year or so, we'll be out of solar minimum and start getting some more activity. But they're predicting for the next 10 years or so, it looks like it might be kind of a safe time to travel through the solar system and not get zapped by the sun.
And of course, if you really want a star that's really in the Earth's backyard, at 6 light years, there's a Barnard star.
Mm-hmm.
And it's a red dwarf. Waiting for someone to start singing the theme song.
I kept, those words. I used to know those words.
Yeah, I know. Me too. It's terrible, isn't it? But as I say, Barnard star is so faint that if it was the same distance from the Earth as the Sun, it would only appear 100 times brighter than the full moon, comparable to the brightness of the Sun at 80 astronomical units. As I say, I suppose these, and at the speed of light, 6 light years, so that's 6 years ago for Barnard star.
Mm-hmm.
And for Epsilon Eridani, we're talking 10 years ago. So pretty much we're seeing them pretty reasonably in real time. Now, the other names, of course, for Barnard star is Jalise 699. And I believe it's also been known as Proxima Ophiuchus, or Ophiuchi.
Ophiuchus.
Fucus. Yes, and same to you. I hope it gets better. We got to have some fun, haven't we, Marty?
Indeed, yes.
Yeah. Proxima Centauri is currently the most closest star. It's at 4.24 light years. In fact, by 11,800 AD, it will be at Barnard star will be at its closest pass to the sun. So,
I've
interesting
never seen Barnard star. Never tried to look for it. I should do that. Just put it on my check-off list. I've gotten all the major solar system objects, a few asteroids, Pluto, of course, but never gone for Barnard star.
But it's interesting. It's an interesting little object. What else can we tell you about it? Its mass is about 0.144 solar masses, and temperature is 3,134 Kelvin plus or minus 102.
That's a cool star.
It's a cool star, and it's at about its age is 10 to the power 12 giga years old.
It'll last longer than our sun, also.
Oh yeah, because it's not running through its fuel as fast as the sun is.
Mm-hmm.
And then eventually our sun will become a close friend to Betelgeuse, because it
Mm-hmm.
will become a red giant, until it then goes down to a white dwarf, and that's probably about it. The sun isn't big enough, heavy enough, and bad enough to turn into a supernova.
That's correct.
It
Doesn't
will go
matter.
partly into the
Yeah.
graveyard of stars.
Compared to the Earth, I mean, as far as saving the Earth from destruction, no, that's still going to happen.
No.
But it's just not going to go kablooey.
Yeah. So we're kind of lucky. We
Mhm.
have a nice quiet G3 star. It's a variable, as a lot of people are suddenly realizing, because there's been a lot of solar activity, and we're supposed to be in one of the deepest, most recent deepest minimums rather, for a long time. In fact,
Mhm.
they reckon even the next solar cycle, it will not be that much improved. Are
Yeah.
we heading to a Maunder minimum? That I don't believe. It would take an awful long time to prove whether or not this is the beginning of a Maunder minimum.
Right. Well, not an awfully long time, because if we miss solar maximum next time, which is in like 5 years, we'll have a pretty good clue we're in some sort of Maunder minimum, but don't know how long it would last. But yeah, once the maximum disappears, and then we're definitely into a cooler sun period. The sun definitely is cooler during solar minimum. Um, Even though during solar maximum there's a lot more sunspots, but the sunspots are associated with active regions, and those produce a lot more energy and actually brightens up the sun, sending out more particles. So uh, it actually is brighter when there's more sunspots all over the sun, and dimmer when there's less sunspots on the sun, like we have right now. Also, lack of solar radiation is causing an increased amount of cosmic rays to get through the whole solar system. So, but also we have less. The atmosphere is not as far out, so it's not pulling down satellites as much that way too. So, little bits of good and bad about solar minimum.
Now, the interesting fact is the Maunder minimum started around 1650 and lasted, or 1645 to 1715. Sunspots became exceedingly rare, as noted by the then solar observers. The term was introduced after John Eddy published a landmark 1976 paper in Science. Astronomers before Eddy had also named the period after the solar astronomers Annie Russell Maunder and her husband Edward Walter Maunder, who had studied how sunspot latitudes changed with time. And of course, the period in which the spouses examined included the second half of the 17th century. And that particular period was also known as the Little Ice Age.
Mm-hmm.
The winter temperatures dropped such a degree, really, that the ice on the River Thames was so thick you could actually light a fire on the river and roast an ox. You could drive heavy carts across the river without having to use a bridge, and they weren't going to go anywhere.
Did it stay frozen in the summertime too?
Well,
Remember.
the summer weather was badly affected because there was disruption to crops and everything due to the drop in heat.
Mm-hmm.
The summer itself didn't really happen.
Right.
It was noted that the crops failed in a lot of places, and there was some famine noted due to the actual lack of solar radiation.
What was the name of the Maunders again? What was their first name?
It was Annie Russell and her husband Edward Walter.
Okay.
So Annie Russell Mulder was from 1868 to 1947, and her husband was born 1851 and died in 1928.
Gotcha. Oh, let's see what's happened. Oh, don't forget Jupiter, of course, our most prominent planet in the early part of the evening after the sun goes down, because we've just passed opposition when the sun is opposite the sun for the Earth. So good times for observing Jupiter and its moons. And if you'd like to know more about the positions of Jupiter's moons when it's going to go across the face of Jupiter, go behind it, disappear into a shadow, the website called Project Pluto. It's got the best list for that. So look up Project Pluto if you want to see when good times are for seeing things happening on Jupiter itself.
Now, according to Sprower's law, at the start of a solar cycle, the sunspots appear at ever lower latitudes until they average at about latitude 15 degrees at solar maximum.
Lower, by the way, is the near the equator, not the bottom of the sun, which looks like from the northern hemisphere looks at the south. The bottom of the sun looks like the South Pole. No, lower latitude means near the equator, away from the poles. Go ahead.
So the average then continues to drift lower about 7 degrees, and after that, while spots of the old cycle fade, new cycle spots start appearing again at high latitudes. Mm-hmm. So the visibility of those spots is also affected by the velocity of the sun's surface rotation at those various latitudes. Is the red spot still there? Yes, it is, Glenn. For now, it is still there.
Mm-hmm. Interesting swirls happening around it. But, it's definitely still there. And it's smaller but darker red, so a little bit easier to see in that context. Get out and look for it. The Jupiter rotates like once every 10 hours. So pretty much anytime you go out at night, or I should say any night you go out, you'll be able to see the red spot sometime during that night. Might be early in the morning, might be the beginning of the evening, but if you just figure out when, there's different websites that tells you when the sunspot, the great red spot will be dead center on the sun. There's a good clue that you'll be able to see the great red spot sometime during the night on Jupiter.
Now, this was a link our radio director put into our Skype chat, so we'll share it. Bill Nye and the Planetary Society are set to ride a sunbeam with the LightSail 2 solar sail. So you can check out Google Maps to see where LightSail 2 spacecraft will be orbiting. This is on Monday, June 24th. The Planetary Society will launch LightSail 2, the first spacecraft completely propelled solely by sunlight. It's been made possible by crowdfunding. It won't be the first spacecraft to use a solar sail at home. The honor goes to a Japanese spacecraft, Icarus, which launched in 2010. But this is a very important extension of the technology. The Planetary Society twice attempted testing solar sailing. In the past, LightSail 2's predecessor, a test mission called LightSail, launched in 2015. 10 years prior, they had a LightSail dubbed Cosmos 1, but that was lost due to rocket failure. And according to Bill Nye, the mission taps into a long-held dream inspired by his time spent 42 years ago sitting in Carl Sagan's classroom and listening to him talk about solar sailing, according to Bill Nye on a media teleconference held yesterday, June 20th. I think it's a great idea, actually.
Mm-hmm. Go sailing the solar system. There you go.
Why not?
Here's a real quick one. NASA's developing 2 new missions for studying the sun. One is called PUNCH. That stands for Polarimeter, to unify the corona and the heliosphere. And TRACERS, which stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites. So look for 2 new solar missions coming out of NASA when they get there. We'll let you know when that's going to happen.
And of course, the really good thing about this is that, glad you could join us, Red Shirt 3. Always good to have you. The thing is about these solar missions, it allows us to learn more about our star. And more importantly, it gives us information about other stars. Mm-hmm. Well, Marty, I think it's time to
get out of here.
Okay, Chief Engineer Rob. This is the away team. 3 to beam up. We're ready to come home and debrief the captain.
Thanks, everybody. Appreciate you all listening to. Don't forget, we got another program, First Light, coming up, and then Jodcast after that. Thanks, everybody, in our chat. Good night, all.
Seeing you.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.